Afternoon, everybody. Today we will discuss the half-life period of a second order reaction. So we know that the integrated rate expression for the second order reaction having the one type of reactant is K is equal to 1 by T into 1 by A minus X minus 1 by A. So in order to find out the half-life period, we have to substitute T is equal to T half and X is equal to A by 2. So our A minus X become A by 2. So see here K is equal to 1 by T half into 1 by A by 2 minus 1 by A. So this is the calculation, that's equal to 1 by T half into 2 minus 1 divided by A. So T half K is equal to T half into A. So T half is equal to 1 by K into A. That means the second order reaction, the half-life period is inversely proportional to the initial concentration. And for the first order reaction, it is independent of the reactant concentration. So for the second order reaction, T half is inversely proportional to the initial concentration. Now, in order to find out T equal to 3 by 4, we have to substitute X is equal to 3A by 4. So our A minus X become 1 by 4. See here our A minus X become A by 4. So we will get T 3 by 4 is equal to 1 by K 3 by Ka. So for T equal to 1 by 4, we have to substitute instead of X, we have to substitute 1 by 4. So A minus X become 3A divided by 4. Okay, so the problem of T 3 by 4 and T 1 by 4 is very important. So you should note that instead of A minus X, for T is equal to 3 by 4, we have to substitute A by 4. And if T is equal to 1 by 4, we have to substitute 3A by 4. Now the graphical representation of the second order reaction. Here the x-axis is the T and y-axis we will represent 1 by A minus X and the slope is K, positive slope, and the intercept is 1 by A. Now if our integrated rate expression for the second order reaction having two different reactant, then and in the graphical representation x coordinate is t and y coordinate is 2.303 divided by a minus b into log b into a minus x divided by a into b minus x. Now these are some of the examples of the second order reaction. So one example for the second order reaction is the saponification of ester. So here ethyl acetate and is undergo the hydrolysis in the presence of sodium hydroxide as the base. So we will get sodium acetate and ethanol. So this is the rate expression for this reaction. Rate is equal to K into concentration of ester into concentration of the sodium hydroxide. These are the other example: benzoin condensation and gas phase dissociation of hydrogen iodide and gas phase thermal decomposition of the chlorine monoxides. Now we are discussing the general characteristic of second order reaction. For second order reaction, all the second order reaction must obey the integrated rate expression, and the unit of second order reaction is mole, liter inverse and second inverse. Next is the half-life period is inversely proportional to the initial concentration of the reactant. Next is the plot of 1 by A minus X against T will be a linear and the slope of the linear equation is equal to K. Now we are moving into third order reaction. Again we can classify the third order reaction into 3A or 3 different type of reactant involving in the reaction. So for this chapter we are mainly concentrating the third order reaction having only one type of reactant. So our general equation is 3a gives product. So we will get the integrated rate expression as K is equal to 1 by 2T into 1 by A minus X whole square minus 1 by A whole square. This is the integrated rate expression for third order reaction. Now again we are moving into the half-life of a third order reaction. For that we have to substitute, instead of x we have to substitute a by 2 and t become t half. So our integrated rate expression become k is equal to 1 by 2 into t half into 3 divided by a square. So t half is equal to 1 by 2k into 3 divided by a square. So here also we can see that the t half is inversely proportional to the square of the initial concentration of the reactant. Now this is the graphical representation. See here we can see that the x coordinate is always t and y coordinate is 1 by a minus x whole square. See here the slope is 2k and intercept is 1 by a square. Now these are some of the examples of the third order reaction. Gas phase reaction between NO and H2. So we will get 2NO plus H2 gives N2O plus H2O. So the rate is equal to K into NO whole square into H2. Next example is the gas phase reaction between NO and Br2. So the reaction is same. 2NO plus Br2 gives 2NO-Br. The rate is equal to K into NO twice and Br2. Now we are discussing the zero order. Before that we have to discuss some of the general characteristics of the third order reaction. So first one is every third order reaction obey its integrated rate expression. Second one is the unit of the second order reaction. General equation for the unit is mole 1 minus n, liter n minus 1, then second inverse. So this is the general equation for the nth order. So instead of n we have to substitute 3. So mole raised to minus 2, liter raised to 2, then second inverse is the unit for the third order reaction. Then half-life period, again it is inversely proportional to the square of the initial concentration. Then next point is the graphical representation. Now we are moving into the next order reaction, that is zero order reaction. Zero order reaction means every photochemical reaction depend upon the intensity of the light. Some reaction does not depend upon the concentration, it only depend upon the other factor. For example, photochemical reaction in which it is only depend upon the intensity of the light. So we will write the general equation for the zero order reaction is A gives P, product. Rate is equal to minus D into concentration of A divided by dt, that's equal to K into concentration of A to the power 0. So rate is equal to minus D into concentration of A divided by dt, that's equal to K. I hope that you understood this, the half-life of second order and graphical representation of the second order and unit of the second order reaction and general characteristic of the second order reaction. Then integrated rate expression for the third order, half-life of third order reaction, some of the examples of the third order reaction and general characteristic of third order. Thank you.